So good afternoon, everyone. Welcome to the next session of the Power Platform Master Series. Really looking forward to today's conversation. So we're going to kind of dive into how to be fiscally responsible with AI and how to leverage the Power Platform to help us optimize our AI spend. Before we get started, if you're new here, let me just go ahead and welcome you. I want to start off just by letting you guys know, a couple things about the Master Series itself. The Master Series is a virtual education series for the community, and it is intended to cover topics that purely surround the Power Platform. It is also intended for Power Platform enthusiasts and makers, administrators, newbies, anybody that's kind of dipping their toe into the platform. We try to offer a session at least once a month. Sometimes we have a few more than that, kind of depending on the topics and the engagement that we're getting from our sessions. And also, we also try to have these sessions as virtual teams webinars, but we have had in-person events in the past. So we hope to spin some of those up in the future. And then the intent of these is really to both educate you guys and also learn from you as well. And last thing that I'll say is that the Master Series has also got a website that we're referring to as the Power Platform Master Series Hub. On the hub, you will find links to any upcoming sessions that we've already got scheduled. You will find assets as far as recordings from previous sessions. The recording from today's session will also be put out there by the end of the week. Any slideware that our presenters have shared, and recently I've begun putting some of the AI notes that get generated throughout the meeting. Feel free to bookmark the site. Like I said, it's a continuous work in progress, so things will continue to change and new content gets added fairly regularly. So before I hand things over to Nico and Scotty, everybody's microphone, you do have the ability to come off of mute, so please feel free to join the conversation if you've got any questions along the way. Please feel free to interrupt Nico and Scotty. Assume y'all are both okay with that. If not, if you would prefer to put the question in the chat, or there's also the Q&A portion of the webinar, feel free to put them in there. We'll do our best to address those in real time. And if we're not able to address them in real time, we'll get back to the team or to the group with the response. So without any further ado, I'd like to hand things over to Nico and Scotty. Guys, thanks so much for joining.
Hey, Jet. Thank you. Hello, everyone. So hope you guys, everybody's excited for 45 minutes on the Power Platform Master Series, discussing how to reduce AI cost, keeping the same accuracy. So I am Nico Sprodi. Today, I'll be covering the Power Platform no-code stack of the solution. And with me, I have Scotty. That would be because we will be going into Azure AI Foundry. So Scotty will cover that part. With that, here's Scotty. Do you want to say a word, Scotty, when I take over?
All good. You go ahead and get started, Nico. And when you're ready to hand it over to me, I'm ready to catch the ball.
All right. Beautiful. All right. So I like to start big. I like to start at 10,000 foot. So when we think at Microsoft, we are a mission company. Our mission is to empower everyone and every person and every organization on the planet to achieve more. So empower everyone and every organization. This is Power Platform. And on the planet, it is important because while we are chasing cost, even when we think even bigger than that, when we are not wasting, we are making an impact on the planet. So in fact, a month ago at Davos, our CEO, Satya Nadella, sit down with Nicholas Thompson, defining, what kind of metric we could design to understand the cost of AI and how to understand how to waste less with AI. So token per dollar token per watt per dollar, the sweet spot where energy compute, power, and intelligence meet. Will be a game-changing formula for driving GDP growth. Great to chat about with Nicholas Thompson today. So I encourage you to kind of, there is a quick video of 15 minutes. It is super interesting. So now going into today, how are we going to translate that from today? So here is our agenda. So first, we're going to cover the tools. What the tools are we going to use? Because we're going to do live demo a lot. So which tools are we going to use? So we're going to get a quick overview of Azure AI Foundry, what we're going to use in there, and same thing with the Power Platform. From there, really focus on our problem statement. This is the most important thing in AI. What is asking ourselves the right question? So here we'll take the classic common example of customer feedback classification to calculate the net promoter score. And then from there, we'll go into the solution. So start from the CSV, upload that in data, start from the CSV, Power BI, upload that in Dataverse, start building our benchmark. So we'll use leading model like O1. And after that, we'll launch bunch of model in parallel with Power Automate. We'll finish with obviously going into Azure AI, how we can hopefully fine tune all of those models and get a better token per watt per dollar. Voilà. With that, Scotty, over to you. Would love to have an overview of all the good features and function of Azure AI.
Thanks, Nico. I appreciate it. Hey, everybody. I'm Scotty Gresham. I am a data and AI solution specialist. I work with Nico, Jeff, and the team, and David. I focus more on the Azure pieces and parts. You heard Nico say we have a lot of tools. Part of the tools we're going to talk today is about how to take advantage of AI Foundry along with the in the Power Plat mode. So I'm a guest here today, going to help with a couple of tools that we want to introduce you to. So appreciate that, Nico. I am going to start with a couple of slides though before I show you some real things. So I'm going to share my screen, and then we'll talk about a couple of things, introduce some concepts, and then we'll jump into some actual showing it. Okay, if everybody's okay with that. Everybody hear me okay? Am I good? I'm coming in loud and clear. Everybody can see things?
Perfect.
Yep.
Awesome. Good. All right. So here goes some sharing. If I can find the right screen, find me a screen. There it is. And we shall share screen. All right. Is everybody seeing a nice green slide?
Looks good, Scotty.
All right. Excellent. All right. So again, we're going to focus. Remember, Nico introduced the idea that Satya talked about with respect to focusing on optimization, specifically around power and consumption. So token per watt per dollar means that we don't always have to light up the biggest, baddest, fattest, smartest AI module on the planet. There's sometimes time for smaller tools, right? We use smaller screwdrivers, smaller wrenches for more fine work. So no different with us today. I wanted to show you a piece of how this can kind of fit together, because when you're working in Copilot Studio, you're in a SaaS, graphical environment, but you can reach out and touch some of these other pieces. And Nico's going to actually show that today, but I wanted to show the relationship of the stack. Right, you can be using Visual Studio Code, you can be using GitHub repositories and so on, but then take advantage of the Azure AI Foundry. So when we put all these things together, we can try and accomplish Satya's goal of the best answers, the best, most accurate solution, but at the best, most optimized cost scenario. The AI Foundry is a big set of tools. It's very similar to the Copilot Studio, and that's meaning it's got access to all sorts of models, not just large language models, but other types of models that can be built in Azure. So these can all be reached out, like Nico will show how we can write and reach out to these other REST APIs to accomplish our goal. And specifically, we're going to reach into some small models, which I'm going to show you here in a minute. This is too small for everybody to read, and I'm not expecting you to read it. The point is to show that the AI Foundry gives you access to many of the tools found across Azure that we can team up and increase the effectiveness of the Copilot Studio. And you hear us talk about agents a lot today. We're going to talk about agents, and agents. The whole agentic model is a way to use smaller agents to get tasks done for the bigger piece. So if we build out an agent and say, you know tools, and then build out another agent that says, you know costs, and build out another agent that says, you know my customers, right? We'll have a very effective scenario, and this is kind of how they look when they're moving or working together. So agentic or working with agents is a very great way to optimize, because we're not going to use 5 big honking models. We're going to use maybe 1 honking model and 4 or 5 agents that are smaller below to help our efficiency. I hope everybody sees that as a valid way to move forward. So now, I told you I would only show you a couple of slides, and that's it. I'll make my promise. So what I'm going to do now is go into the Azure portal, the AI Foundry, so that you can see kind of a couple of things I'm talking about today. All right. Here's my Foundry. I'm at the front page of the Foundry. I happen to have a couple of AI hubs, which is a way of collecting projects. And in those hubs are a few projects. I'm going to, before I go into the projects, before I go there, I'm going to show you that one thing that's interesting and a concept we're going to leverage today is the Azure Foundry catalog. So we know that we predominantly take advantage of the GPT-4o model. It's a very competent model. It's well-trained, and it's very useful, very utilitarian. But we can use more precise and smaller models in agent format to get things done. So when I look at our catalog here, notice over here, 1,874 models. So we have no shortage of how to choose and be optimized. And what Nico and I discussed today was to talk about our Phi models. So Microsoft, in addition to having the OpenAI and the Meta and the Mistrals and the Hugging Face and pretty much every model on the planet, we've got them all mounted here so that you can take advantage of them from the Copilot Studio. We're going to talk about the Phi models today, specifically Phi 4. And so see these little guys, these are more like small language models than large language models. They're still competent, but they're trained with a much more precise set of parameters. And this is a model we can come here and determine, is it the right one? What is its benchmarks? What is its cost? Look at this little guy, 65, no, they don't, the cost isn't on here, but this model is something like 26 cents per million tokens or something. It's very, very cost effective. We can look at the benchmarks and make sure it's the right model for cost and effectiveness. Okay. Now, one technique that helps us accomplish our goal with Satya is to do some fine tuning, because if you add some fine tuning to a model can be more precise and answer more effectively. If a model has to dig into its knowledge base and respond, sometimes it'll respond with more tokens than is necessary. If we fine-tuned it, it might have a more precise answer. So I'm going to show you real quick the notion that in the AI Foundry, we can take any one of those models, most of them that I showed you a minute ago, and we can fine-tune them. I can come to this fine-tuning area here, and I can say, fine-tune my model, and it'll say, oh, really? Which one? And I can pick my Phi 4 model, for example, and say, yep, let's do that one. And then I can make this model available either on the platform, is what we call serverless. So you just have a URI and a key, you're done. Or you can actually push it onto some VMs or containers that you manage to where you're in control of the compute. So I'm not going to do the fine tuning in front of you. This is like the good old, I've got 2 ovens and the cake is already baked in the one oven. So I just want you to show, this is a few steps where we provide the training data, say go, it trains up. And then when we're done, we end up having a trained model, a fine-tuned model. And here's an example right here. So this model right here has a key and a URI, and it's ready to go. And Nico's going to show you a little bit later how he takes advantage of this. But first, we went into the Foundry here. We found a model. We gave it a fine-tune. We mounted it up, and now it's ready for use. So this is one of the main aspects to help us be optimized and precise with our models to help accomplish our goal. Nico, I'd like to pass it back to you unless you have something else you'd like me to cover.
This was great, Scotty. Perfect. Thank you.
All right, fantastic.
Here we go. All right. Let's get into the demo. Oops, on Power Platform briefly, because we're going to touch on Azure AI, and then we're going to bring the no-code, low-code of the Power Platform to build our entire solution or entire demo. So today the demo will be a mix of those two worlds, Azure AI and Power Platform. We just cover Azure AI. In the world of Power Platform, we'll use we have 5 key bricks. So obviously everyone is familiar with Power BI, analytics. Then we have Copilot Studio completely on the left. So Copilot Studio, think of it as the user experience layer for chat. So in there, we will have all the orchestration mechanism to call multiple models at once when maybe the user asks just one question, and sometimes we go to Azure AI. Then you have Power Automate. So Power Automate on its own is a full model for enterprise automation. But also Power Automate is being used as a feature within Copilot Studio and within Power App, almost like if I use Copilot Studio, I can use Power Automate not almost at no cost. And then Power App. So Power App is mobile framework, putting lipstick on top of my backend system. So they may be SAP, they may be mainframe, or hopefully Dataverse. On the bottom here, just Dataverse is, or on one hand, it's a glorified spreadsheet. On the other hand, it's a full business application development framework, right? Where all the security, the scalability, the control, everything is in there, including the ALM process. Then Power Pages. Power Pages is the brick of Power Platform. I like to think of the Wix of enterprise. If I want to crack up a good enterprise website for my customers in no time, bam, I can do that in Power Pages, and I can go to almost pixel perfect. The key with Power Pages is the portal, because Power Pages, not only I can crack up a good website, and I have also all the security to expose those enterprise data that hopefully I have in Dataverse securely and safely to my customers, so they just can see their PO, their receiving, and so on. On the bottom right is AI Builder. So we've seen Azure AI. Think of it as Azure AI already is no code, but you need to deploy. You have an API. It's good. Think of it as AI Builder as Azure AI in no code even more. Like here, we'll find like 20 models that are like, I call it the selection of the chef. You have obviously 4.0, 4.0 mini. We even have 0.1. So we'll use AI Builder to test, prototype, and then we'll go to Azure AI when we go to production and full deployment of volume. 1,000 connectors. This is a mini big deal because what it means is the platform comes out of the box with now it's 1,800 connectors that connect to obviously your emails, your SharePoint, what have you, but also to the Salesforce out of the box connector, ServiceNow out of the box connector, Workday, blah, 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 blah. So all of those, they are there, and they are there to almost ensure the telemetry and the security of the stack. So we can truly decouple and fully empower almost non-developer by extracting all the connection to those backend systems and having a proper telemetry and governance with those connectors. So that's the tools we're basically going to use today. What are we solving? Customer feedback. So basically what it is in about every industry, we need to measure how my customers are happy, gather feedback, and hopefully drive process improvement. So for that, there is the Net Promoter Score, NPS. So it's a KPI to monitor the customer loyalty and drive improvement initiative over time. It is calculated by first classifying the customer feedback. So I take one feedback, is it promoter, passive, or detractor? And then subtracting the percentage of detractor from the percentage of promoter. So we forget about the passive in the middle and we just do the subtraction. So along with the NPS score, additional insight are typically gathered. So, here it's like airline industry, but if it's logistic industry, it will be the feedback coming from the warehouse, delivery, or here it will be onboarding and that type of thing. So to know where we can improve, right? So in this session, we explore running cost-effective AI to classify those customer feedback. So we're going to go one by one. So we're going to start from a spreadsheet. And literally, like we could get any spreadsheet from any department in your organization where we have a list of feedback, just plain text. And we have an ID because we just put an ID, but more importantly, we have those feedback and they are not even classified. We don't even know because they get, it's not like we downloaded them on Kaggle or something like that, right? So we just have those feedback. So what do we do with it? The idea here is first, and I'm going here in Power Platform. First, I'm going to load the spreadsheet in Dataverse. So like, remember, I said, oh, Dataverse is on one hand, is a glorified Excel spreadsheet. This is here, my IDs and my feedback. But then what we can do, now we have that spreadsheet in Dataverse, it takes no time to add columns to the record. So we're going to go and click on the record, the first feedback, and we're going to look at a couple of columns we've added to the table. So this is my feedback, great. And then we added the first couple of columns is benchmark, because we don't have a benchmark. So I want to know, even manually, I want to say, take 100 records and say, okay, this one is saying the flight was late taking off and I got charged an unnecessary fee. So manually, I can take 100 records and say this is detractor. And by the way, this is on-time performance. And I can do that for 100 records. That's my benchmark. And after that, I can start working from there. But here, what we're going to do first is, let me take a record that we have not processed yet. Yeah, that one. That one is a blend feedback. I have a benchmark. I'm going to delete the link tag and then set it. The first thing we're going to do is pretend I don't have any benchmark for that record, is use O1 to process or to basically give us a first level of benchmark, because O1 is so good that, I mean, there is no mistake, honestly, and then so there is no mistake. So the idea here is we're just going to say for this particular record, launch O1, and I'm going to save it. What's happening in the back is there is a Power Automate flow that listens to that table. If the status of a record change from benchmark, from nothing to benchmark, trigger, launch O1, do the extract, and update the table. So if I refresh, it is processing. So it's O1. It takes a little bit of time. It is processed, and now I have my benchmark that's just been just deleted before, but I just processed that for that particular record. I used O1 to basically do my benchmark. So now back to my data set. I have a view here, and I'm just gonna filter, and I'm gonna look at my benchmark right here. So all of those, I have 100 records that we're gonna work with today, and that's basically a couple of records that I've selected, that are cool on the edge. We can add plenty, but those are like just 100 records. This is a human, easily workable, but at the same time, it's also almost not representative, but almost start to be representative of the data. All right, let's go in the mechanic, because I skipped from Excel to the application. Just to show you under the hood what we've done. So first, we created a table with my spreadsheet. So I am in Power Platform here. I'm in a solution, and in a solution, we can have a table, an app, a Power Automate, a chatbot, and so on. The solution is used for the deployment process later on. So here I have 3 tables. So all we have to do for the Excel spreadsheet is just table and create a table. And then it's going to ask me, how do you want to create your table? So I can create it like the good old-fashioned way, like I declare every columns and so on and so forth. Or I can start straight from my CSV. So basically will be imported the CSV in Dataverse. But there are plenty of very Power Platform enthusiasts that use SharePoint as a database. This is not good practice for total cost of ownership of your solution. So whenever you're ready to migrate your Canvas app on SharePoint to Dataverse, you can straight import from the SharePoint list and from Copilot and so on. So just to show you the import process of creating the table. Now, on my table, so this is, oops, not that one, this is that one. So on my table, I have my columns. When we create the table in Dataverse, it is an application development framework. So it automatically creates, who created the record, who changed the record, when it was the last time, and all of those like 10, 15 core business application columns that we are supposed to carry in every table, we don't have to create them, right? So this is the type of thing that makes it much more faster to go from prototype to production. So here are my columns, right? For my columns on my dataset. So obviously I have the feedback, and then after that I've created, the benchmark NPS, and then for each you can say if it's a single text, if it's a yes, no. You can even obviously make a relationship, one to many, and so on. Right? So this is like database. You can even add a column type file if it's and then treat it as a column, and then behind the scene it will be just doing like blob storage and that type of thing. The key concept, when you show me, the app behind, is we have views. Views are like no more like how we're gonna view the record. So almost like a tab on your spreadsheet. So the main view is that one. That's the one we were looking at. And then I have my column here. I can change the order, drag and drop. I can click, add columns, filter, and have multiple views with different filters depending on the user profile. And I can sort by, and so that is my view. And so that's the first key component you want to do when you create a table. And then the second component is, remember when we went into the record, at this point we are editing the record on my Dataverse table. And for that, we are using the concept of form. So form, we didn't invent anything. The concept of form was there at Oracle 20 years ago. It is essentially dragging and drop your control on how you want to update that particular record. So views and forms once you have Dataverse, and then you can build, and then it takes no time to build that the menu, and then you have to build the menu for that app, and then you're good to go. So that's for the mechanic of in the backend on how to build a model-driven app on Dataverse. All right, let's get into our Power Automate. So you guys remember we changed the status to 01 for the benchmark. So let's look at that first flow, what happened in the backend. So feedback classification, 01 benchmark. This is the Power Automate flow that triggers when we change the status to 01 and we want 01 to crack up the benchmark for us. So when we open the flow, it's coming with me. So 5 minutes ago, that was us, all right? So if I did the flow, that was the log just there. It is pretty simple. All we're doing is, so this is the trigger. When a row is modified on the dataset table, just for that particular column, so this is the status we change, and the status that column is 01 benchmark equals 0. That's so basically every time we trigger. After that, all we're doing here, remember we had we changed the status to processing. So we're saying update that particular record to processing, show all up to processing. Okay, now we know we're working, and now we're calling 01. 01 in AI Builder. So 01 is in no code. So this is the prompt we are calling. So this is the prompt we are calling, and we're passing the customer feedback. All that prompt is doing is responding with a JSON record with is it a promoter, passive, or detractor, and update after that, update or same record, update the data set like we saw it on the benchmark. So let's look up that prompt. for that, we're going to use AI Builder. So again, Azure AI in no code. And here I have 3 prompts. So the one I want to show you is the one with O1. So on the left, we write the prompt. So here you are an expert at classifying feedback from airline passenger. Here's what the customer say when being asked to provide feedback. So if you remember in Power Automate, this is the trigger, and then we're passing that into the prompt. That's the variable here. Your goal is to classify this customer feedback and answer in a JSON record in the following format. So we give the format of the API, language, insight, and whatever is the NPS. Where NPS can take only one of those 3 values: detractor, passive, promoter. Insight is the context of the survey. It is where in the travel the feedback is coming from. So check-in, check-in, gate, boarding, and language is the language of the feedback in the format English, French, Spanish. And then, so here we can also, because when we're building that prompt, you're going to have to iterate, you're not going to get it the first time. So you want a mini playground. And that's what allows us here is like, here I can say feedback. And then, so I'm declaring the variable for that prompt, but I can put the sample data, no, everything was fine, and play with it, well, and change it as I want. So if I say test prompt, it should take a little bit because this is O1. And voila, I have the JSON already parsed properly. And then in Power Automate, I will be able to access those fields right away to update my table. So the way it works is here in my AI Builder, I can choose O1, so that's where I am, but you could do 4O or 4O mini. So everyone, like the consumption behind in the backend, obviously, is not going to be the same price. But as far as iterating, and in the spirit of iterating and trying to run the same accuracy at a cheaper cost, right here you have it already, right? So that is important. And the other thing is for the data science people in the room, not with the one, because it's a different type of model, but for 4O and 4O mini, you have access to the temperature, which is when, we can call in API, we can change the temperature or the top P. So here we have the temperature. And the important thing is those models, now those OpenAI models have a capability that you can force the output in JSON. So we're using and abusing that feature here and make it available for the coder. So if you select JSON, the model will enforce, we test it, look at the JSON format, save it for you, and then when you launch the prompt, you won't have anything to do, right? You can even edit the format of the JSON output. So we're going to do that. So what we're going to do here, we just launched. So now back to Power Automate. Oh, let me show you back to Power Automate. We just feeding that model and getting that and getting our answer. So if I say no, everything was fine. I know I put this example because it is a good one. Ask yourself, is it promoter, passive, or detractor? Not easy, huh? So I would say promoter, passive. So O1 says passive. Because I'm playing with that one because here we are on the edge of classification. We are just on the on the S curve. So this is a good one. Let's change the model. So let's go with 4O. See what 4O has to say. 4O say it's a promoter. And let's ask for O mini. It's passive. So the reason I'm showing that is because, if you're here in the world of data science, they say, oh, past like 80, 90% of the benchmark, makes no sense. This is where we are here, right? All of those models we're going to mess around with today are like above 90% accuracy. And after that, we are on the edge of classification where even a human, two humans may disagree. Voila. So that was for AI Builder. Okay. So here we go. So I'm back on O1, just prompting O1, and then from there, putting straight the data inside NPS exporting into the table. So that was for our benchmark.
Hey, Nico. Hey, we've got a question before you kind of move off of this subject that I want to see if we can get addressed. So if incoming feedback is a large text set, since maybe it might be dynamic that's coming back in, do we hit a token limit with that?
No, because the key here, we are not processing a batch. We are not processing per feedback. We are trading every single feedback at once. It is a very good question, because in effect, what we're doing, we're parallelizing the workload. And then we are focusing the prime, like even as a human, I'm not going to, if I'm giving me a spreadsheet, I'm not going to work all of those comments or feedback at once. I'm going to work them one by one.
Yeah.
So we are not processing. This is important because that's Power Automate that allows us to do that. Essentially, by just changing that field, we leveraging kind of Power Automate in a almost asynchronous way, right? So I could update if we run like 100 records to run is less than a minute or not even. Right. So back on my benchmark. Now we have my benchmark at the record level. Now all it is but running all of those models against our benchmark. So that's all we're doing here. We create a new table, and that's all we're doing here is every time we change the status, run a flow for O mini, run a flow for O, and then we'll get in a minute, run a flow for 5.4 on Azure AI. So basically here for my feedback, O1 is obviously correct, GPT-4o is correct, FIO is correct, and so on. But if we want to look at all the output for our model, so let's say I'm going to sort that by. So you can see correct. We're going to hopefully see some incorrect. All right. So you see O1 is correct, 5.4 is incorrect. So we did that for 100 records and run all of those models in parallel. So if we look at if I show you Power Automate for these two others, for the two other I lost my flow. All right, so we just launched that one. Let me just quickly open that one, but you're going to see this is exactly the same one, almost the same one, except that now we're not saving that from data model perspective. We're not saving that at the benchmark level. We are saving that just in another table where we can just track all of those outputs. But the prompt we're calling is the same as we were calling with O1, just with a different model. And then like here you have it, when I change the status to 4.0, or when I change the status here to 4.0, update to processing, ping 4.0 in AI Builder, add the output to the model, and tell the original record that we are done processing. And now we do have a full table of output we have a full table of output. Now let's get into 5.4 prompting, because that is a little bit slightly different. The way it works is we're going to do few-shot prompting. So few-shot prompting, it is essentially you tell the model, hey, this is the question, this is the answer. This is the question, this is the answer, this is the question, this is the answer. And at some point, you're going to say, this is the question, give me the answer. So it's kind of like few-shot prompting. It's like showing the models, don't tell him, like even almost don't give him any instruction. Just give him the question pair, and at some point you stop, and then you hope you're gonna at some point, like you give it 10, 11, 12, and then at some point you ask it to just answer your question. So that's what we're gonna do with with 5.4. So let me open the flow when 5.4 trigger. So starting from our same record, same data set, but here the 5.4. No, this is not 5.4. Oh, la 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 la. Okay, this one. Here we go. So same spirit, we're working from the same table. When the process status change, but here just they go to 5.4, update the processing, and then we get the model information. So we'll see in a minute, we just store the URL and the key in a table. So we get the table, the model information, initialize the content, we initialize few variables, and then here we are going into our data set. We are going into our data set, and we have selected few records to do few short promptings. So all we're doing is selecting these 10, 15 records pair, and then we put the question and the answer, building that text, appending the actual question, appending the actual things to classify, and then from there, HTTP or model on Azure AI. So if we want to go check it quickly on the Azure AI, where to Scotty's point, I'm not a developer. This is no code, right? I was able to deploy on my Azure AI hub 5.4, Meta, DeepSeek, and so on. So here I am just pinging 5.4 turtle model at deploy serverless on Azure AI Foundry. And then it gives you, if you go in there, it'll give you all you need is the chat completion route and the API key. So all we're doing in the Power Automate is then from there, calling the HTTP model right here. We're passing all the table we have constructed, passing the output, and back on our foot, adding a model output and updating the record. So if we want to look from an application perspective, how does it look like? I have a view where I have, not in the data set, I have a view that those are just the few short learnings we are using to prep 5.4, right? So in that case, all we're saying, remember when we say, hey, list all the few short learnings, all we're doing is listing that list, and then we give it an order, because it does influence as well, which record you put first. So this is experiment. And then we give it the output. So we give it question, output, question, output, question, output, and then at some point you give the question and you should get the output. When it goes to fine-tuning, is essentially doing that for many records, and then, or many records, or maybe not sometimes so much, but what it is feeding those records into what Scotty shows you, and then have a model, then you don't need to call these 15 records all the time. So you are even more efficient. So you'll spend a little bit more fine-tuning, you spend a little bit fine-tuning, but then when you infer this model, you will have to spend less token to get an AI response. That's the idea of fine-tuning, and that's how you go, by starting few short promptings, and that's how you go to on fine-tuning your models. So we do have a model table. Remember, I was saying, hey, we have here is where we get the model. So this is here the example of 5.4. So 5.4. We're here. Think it as a spreadsheet. Honestly, this is just I'm storing in a spreadsheet my connection for URL and the key, and I'm just getting in my flow, so I can just create as many models as I want and keep running. Right, and then after that, we have our result. So this is our model. We're running out of 100 records, right? So the benchmark is the benchmark. It is debatable, but we are like within the 90, 95 range. So here is 5.4 at obviously 0.1 at 100. That's our benchmark. And then as we going down in inference, we see some changes, but honestly, these are like classification edges problem. They are not like completely, it was supposed to be yes and it's a no, right? But as we do that, in every output, every time we call the model is bringing us back how many tokens it has used for the prompt and how many it has used for the response. So we track those tokens and we sum them up. And then every time we call those tokens do not have the same price. So here, for our 100 record use case, we are tracking the number of total token needed, both in and out, and making the math here. And making the math here, knowing the completion cost and the prompt cost of, what does it cost to process 100 records with that mechanism. Interestingly enough, you'll see O1, where it's like GPT-4o and 4o mini, they have the same number of tokens, which makes sense, right? But like O1 has way more token for the same useful output, honestly. But what happened is here, all of the extra 40,000 tokens are coming from O1 thinking. So thinking are priced as output token. And even though we don't care about them, and a valuable output it at the end, we kind of paying for it, right? So not only O1 output token are $60 for a million, on top of that, you need more to get a good response. So that makes that to process 100 records between 5.4 in that use case, between 5.4 and 0.1, so this is really the extreme of the extreme. To an extent, this is over 400 times difference value in cost. So the reason I'm bringing that up is obviously this is input, we know that, but sometimes you are in your GPT and it takes no time to switch from one model to another model. Well, even be thinking about the waste for the planet, if you don't need the good AI, you don't have to use it, right? Let's use the cheap one and make it better for everyone. For the company, for the bottom line of the company, obviously this is right thinking, right system design thinking. Voila. So that's my closure. Yeah. That concludes
Hey, Nico. Yeah. Hey, Nico, it's Scotty. If I can interrupt for a second.
Yeah.
Thanks, Nico. Just a quick comment on the O1 model. Remember that an O1 model is that's a deep research model, right? So that's why you're seeing the more tokens from it. It's not a utilitarian model like the 4.0. It's designed. It actually will do a more thorough research, which costs more tokens. And then if you've ever seen an O1 output, it is a very much longer verbose output, which is also the more tokens. So even though it's good to talk about the efficiencies and optimizations of these models, it's not a terribly fair comparison to compare 4.0 and 0.1. They're designed for different things. However, that underlines the point that you want to pay attention to these optimizations, be it fine tuning and the right models you're choosing, so that we are optimizing our cost and just not using a fancy model like 0.1 when we don't need it. So,
well, it was very helpful, Scotty, to do my benchmark, right?
Yeah.
That is very.
I'm not saying I'm not saying it's a bad model. Just pointing out what it's designed. That's a very fancy tool that is designed to do deep research. It does a great job at it. But I just noticed when you were pointing out the differences in those costs, it was a great idea to show those costs because that really illustrates how you can tune your models and use different models to accomplish Satya's goal.
Right. Thank you. It concludes, I think, the demo we had live today. We have 10 minutes left. Happy to take a question with Scotty. Call to action. If you don't have access, go and try ai.azure.com. That will get you straight to Azure AI Foundry, and go to make.powerapps.com. That will get you straight into Power App if you kind of want to start playing and messing around with it. if you can access in your organization, it's happening. Power App is almost like Outlook. You most likely have a team of admin that needs to give you access. So ping your admin, and they should let you. If not, make sure you ask for Dataverse environment. If not, we'll put a link in the chat. There is an access you can also access for free and get yourself a Power Platform developer environment for you to start building. Thank you.
Thanks, Nico. Hey, before everybody leaves, I kind of wanted to feel out where everyone kind of might be right now on their on the AI journey. I've got a couple of poll questions that I wanted to put in there. As far as large obstacles right now with your organization adopting AI, especially at scale, what are the biggest obstacles you guys are facing? Is it a matter of cost, technical skill sets that need to be ramped up? Is it a matter of time to deploy? If there's anything else, feel free to drop in the chat. But do let us know. Okay. So, folks, I really appreciate you guys joining. Nico, Scotty, this was awesome. I enjoyed kind of seeing this and getting a look under the hood, and of course, having an opportunity to see any of the other models in action is always great as well. Before we kind of wrap things up, does anybody want to come off mute? Have any questions? Any sort of feedback? Any ideas on future content that we can also bring to a session? Feel free to come off now. All right. Otherwise, the session's been recorded, so I'm going to. Oh, yep, Richard, go ahead. Do you have a question, Richard? I saw your hand come up. All right. So like I said, I did record the session. I will we'll stop the recording here in just a moment. If you were able to capture the URL for the Power Platform Master Series Hub, I will be posting that up there likely by the end of the week. A copy of the recording along with Nico's slides as well. So, folks, really appreciate it again. Oh, looks like we do have a question in here now. Sorry. Rohit.
Yeah. Hey, Jeffrey, this is Scotty. Rohit's question around deploying a model in Azure AI be automated. The answer is absolutely. All the we show it oftentimes using our UI because it's just easy to explain and show, but all of that can be done via the APIs. You can use the APIs in a variety of languages or PowerShell and other languages to post and build out endpoints. So all completely automated is no problem at all.
Awesome. Yeah, thanks, Scotty. Richard, I see that you might be stuck on mute, and I apologize. That would have been on me if I didn't flip everybody's mics on. Did you want to chat or type your question in the chat or get back to us? Yeah, we've certainly got a guide that I can send you. I'll ping you on the sign, Richard. All right, folks. Thanks again. And like I said, look for the recording and hope to see you guys at the next one. Thanks again.
Thanks all.
Thank you.